Hi there everybody, we're just going to talk about mutually exclusive events today. So it's a probability area. It's something that you'll have probably heard, it's something that you might not even thought about, but when something is mutually exclusive, or two things are mutually exclusive, it's a case of that one thing can happen, therefore the other can't. So they can't happen at the same time. Alright, so for example, it might be a case of you throw a dice, well I can't hit a 1 and a 6. Alright, so those arguably are mutually exclusive. You cannot get a 1 on a dice and a 6 on a dice at the same time. Alright, a 1 on a dice and a 6 on a dice at the same time. It's just not going to happen. Alright, another example could well be when you flip a head and a tail on a coin, you can't get them at the same time. So again, the idea of getting a head on a coin is mutually exclusive in relation to getting a tail on a coin. They can't both happen at the same time. Alright, so if they are mutually exclusive events, alright, so for example the coin, then the two probabilities must add up to 1, all right, because it's either that one or that one, therefore it's going to be either of those two, and that would make it certain. Okay, so it's going to, in this case, for the coin, it's going to be a half and a half, which would add up to 1. All right, so if you're given a probability, and a reminder that probability is often given as either percentages, fractions, or decimals, but is always less than 1, or a whole, or 100%. So it's always kind of under 1. So the probability of rain is 0.8. So what is the probability it won't rain? All right. Well, if it rains, then surely it can't rain and not rain at the same time. So they're mutually exclusive. So it's going to be 1 take away 0.8. All right, because it either does or it doesn't. Okay. So 1 minus 0.8 is going to be 0.2. All right. So the probability John wins a game of snooker is a 3 out of 11. Well, same thing. He either wins or he doesn't. So arguably they are mutually exclusive. So same process as before, it's going to be 1 takeaway 3 out of 11, which gives you 8 out of 11. All right. Right, so sometimes you might be asked to fill in a missing value in a table. Well, actually, you are highly likely to fill in a table of values. I've seen quite an awful lot on exam papers in the past where you've got a bunch of tables with missing values. But of course, you need to be clear that they are mutually exclusive, and often they are. Right, so all values are mutually exclusive, they must add up to 1. So we've kind of just established that one. So well, probably I roll a 5 on a biased dice. All right, so if it's a biased dice, then the probabilities are different. But ultimately, there are 6 outcomes, and I can't get a 1 and a 2, or a 3 and a 4, and a 5, and so on and so on and so on. I can't get both at the same time, so they are all mutually exclusive. Therefore, all those probabilities, which you see here, 0.1, 0.3, 0.25, 0.15, and 0.05, and the 0. Whatever here for 5 must add up to 1. All right. So what you need to do is add up the current ones you've got and then take them away from 1. All right. So 0.1, 0.3, 0.25, 0.15, 0.05 is going to be a grand total of 0.85. So I'm going to do 1 take away the 0.85, which is going to leave me with 0.15, and that must be the probability of getting 5, because as I said, there are only 6 possibilities. So this 6 possibilities in terms of probability is that they add up to 1. All right. I'll mention it now because it's here. The idea of something being biased, that means it's weighted towards one more than the other, because what you would expect for a normal probability of a normal dice is these probabilities to be all the same. All right, the chances of getting a dice or a number on a dice is going to be the same no matter what the number is. But obviously if it's biased, that means it's kind of slanted towards hitting one number rather than another. All right, so it looks like to me it's more designed to hit a 2 and a 3 than it is than the rest of the numbers, and you're less likely to get a 6 than the rest. All right, so that's what bias kind of means. All right, please visit maths-school.co.uk, link at the bottom of the page for a bit more practice and some questions on this. But obviously you're welcome to revisit the video at any time. Thanks for listening.